Hello everyone, my name is Luke Hanks and this is my Physics 2211 Lab 4 on oscillations. So the purpose of this lab, we're just going to talk a lot about the energy principle, and we're going to do that through analyzing some oscillating motion. We're going to do that in Tracker, and then we're going to make a model in GlowScript. So the physics principles that we have here, we have the period equation first with the kinetic energy equation, which is just gamma mc squared minus mc squared, and we're going to approximate that to be 1/2 mv squared because the velocity is much less than the speed of light. We have the potential energy of a spring, potential energy of the due to gravity, which is negative g m1 m2 over r, which we're going to approximate to be mgh because our height is much less than the radius of the Earth. And then we have our total energy is just the sum of kinetic energy, the spring potential energy, and gravitational potential energy. Then we have the force of gravity we're going to approximate as mg, and then the spring force equation we have listed, and then we have the velocity and position update formulas. And then my results are going to show you that the energy principle is satisfied. So here's my observations in my experiment. I'll go ahead and play the tracker video while I talk over it, but the mass, I have 0.402 kilograms, and we're going to assume that the spring is massless just for simplicity. Then we have our initial position is negative 0.122 meters in the x direction and negative 0.634 meters in the y direction and 0 meters in the z direction. Then my L is 0.70 meters. My initial velocity is 0 meters for every direction, meters per second for every direction. And then the spring constant I calculated is 6.88 newtons per meter. And then here is my experiment or my model. And then below you can see the graphs it's generating. So let's move on here. Oops. All right, here's my coding. Basically, this is my just changing the initial conditions to the ball length to the ball's mass, the position and the velocity to be the initial position and velocity vectors in the previous slide. The spring constant and the my L0 that I calculated was 0.127. And then I managed to change the L to be ball position minus spring position. L hat was changed to L over magnitude of L, and S was changed to magnitude of L minus L0. And then I just changed each system energy formula to their respective formula. So let's see what we got here. I have the force of gravity. I changed to be a vector, ball, the mass of the ball times g in the y direction, nothing else in any other direction. Then we have the force of the spring, just the spring force formula, negative ks times L hat. Then we have the net force is just going to be the spring force minus the gravitational force. And then I changed the ball's velocity and position to be the position and velocity update formulas respectively. And then finally, for updating the spring, I just changed the equations to be what they were before in this slide. Same changes. And then for my third coding slide, I just changed each energy to their respective formula. So, for example, kinetic energy is 1/2 mv squared, as you can see up there. And then I also changed each delta of each energy to be final minus initial. And then the total energy is just all three of those energies summed. So here's my data. The blue line is the delta K, the red line is your delta gravitational potential energy, green is your delta spring potential energy, and orange is your delta total energy. And one thing I want to point out here is that the delta E remains constant throughout the whole thing, which verifies that the energy principle is satisfied because any energy change in one type of energy is balanced out by energy changes in other types, and it's just like a flow between energy types, which is what the energy principle is basically talking about, an exchange of energy. And then here's my second data slide. The blue is my model position, and my red is my experimental position. You can see they're pretty close, but not exact. And the one thing that I want to point out is how after each crest and each trough, you can see that the maximum height slowly begins to decrease. And I attribute these discrepancies to be outside forces acting, i.e., in this case, I think it's drag or air resistance, and it's just causing a loss of total system energy, which is, the shorter peaks. Basically, there's a loss of energy in the system to the surroundings. And then, what does it mean? Is the energy principle satisfied? Let's take a look at my energy plot. We've already talked about this a little bit, but yes, it is satisfied because delta E remains constant, and any energy changes is mirrored and change in a different form of energy, and everything remains constant. And then with my data I've obtained from tracker, I have two different oscillation periods. For my x, it's 1.638, and for y, it's 1.519. Basically, I just think this means that we're going to get two different spring constants for each direction, and it also means that we have two different amplitudes that are going to be for each direction. Thank you for listening. That is my lab 2.